Needle valves are generally smaller and longer in relation to their piping than other types of globe valves. As this cutaway illustration shows, a needle valve seat opening has a very narrow diameter. When the valve closes, the disc descends deep into the seating area. A small movement of the valve stem causes a small, gradual change in the flow rate through the valve, which makes the valve capable of precision throttling. So needle valves are often used when precise regulation of flow is needed. Many globe valves, especially those used in steam systems, have a back seat that provides a seal between the stem and the bonnet of the valve. When the valve is fully open, the raised disc seats against the back seat. This prevents system pressure from building against the valve packing and keeps fluid from leaking into the upper part of the valve. In most globe valves, fluid normally flows up through the seating area and against the entire surface of the disc, making two nearly right-angled turns. Regardless of whether the valve is fully open or partially open, fluid flow contacts all the surfaces of the disc and seat, so wear on the valve parts is relatively even. As a result, even after it's been used for throttling for long periods of time, a globe valve can usually retain its ability to close completely. In this part, we'll look at plug valves, ball valves, and butterfly valves. A distinctive feature of these valves is that none of them has a disc that moves up and down from the valve seating area. Instead, each type has a disc that rotates. The rotating disc enables the valve to be opened and closed more quickly than many other types of valves. Also, the valve seat for a plug valve, a ball valve, or in this case, a butterfly valve, is usually made of a resilient material, such as plastic or rubber, that provides a firm fit and a tight seal when the disc closes on it. An operating lever or handle is used to position the rotating disc of a plug, a ball, or a butterfly valve. For instance, when the handle of this plug valve is turned, the disc rotates 90 degrees from the fully open position to the fully closed position, or vice versa. You can determine the position of the valve by looking at the position of the handle. When the handle is in line with the piping that the valve's attached to, the valve is open. When the handle is perpendicular to the piping, the valve is closed. Plug valves are generally used for on-off control in applications that require a tight shutoff, as in this gas line. When the handle is turned, the disc makes a 1/4 turn that quickly opens or closes the valve. When a plug valve is fully open, the ports in the disc, or plug, are lined up with the inlet and the outlet of the valve body so that fluid can flow through the valve. When the valve is fully closed, the plug is turned so that its ports are perpendicular to the valve body's inlet and outlet. For proper operation, the plug has to be able to turn in the seat, but the plug and the valve body must fit closely, so there's no leakage around the plug when the valve is closed. Because of the close fit between the plug and the body, the turning of the plug can gradually wear out the plug and the valve body. If either of these parts wears excessively, it may no longer be possible to completely shut off fluid flow when the valve is closed. Many plug valves, as well as other types of valves, use some means of lubrication to minimize friction between the valve's moving parts. However, some plug valves don't require lubrication. This plug valve, for example, has a plug that's enclosed in a sleeve that's made of a Teflon-like material, which is self-lubricating. Non-lubricated plug valves are especially useful for applications in which lubricant must be prevented from contaminating the fluid that moves through the valve. Like a plug valve, a ball valve has a disc with ports that are aligned with the inlet and outlet of the valve body to either allow or stop flow through the valve. As its name indicates, a ball valve's disc is called a ball because of its shape. The ball is highly polished and its surface is smooth and uniform. A ball valve's disc fits snugly into a ring-shaped two-part seat. The two parts of the seat are called wipers. They're usually made of nylon or another elastic, self-sealing material that prevents leakage. One wiper fits on the inlet side of the body, and the other fits on the outlet side. During operation, there's little friction between the highly polished, smooth ball and the wipers. So ball valves generally don't require lubrication. Ball valves are commonly used for on-off applications. This is a butterfly valve. Butterfly valves may be used for various purposes, but they're normally restricted to low-pressure, low-temperature systems, such as a low-pressure gas line or a cooling water system. They're particularly useful on large volume systems where space is limited. Like plug valves and ball valves, a butterfly valve also uses a disc that rotates. However, the disc in a butterfly valve does not have ports. Instead, the valve has a thin, flat, circular metal disc that is rotated to open or close the valve. The round body of a butterfly valve is also relatively thin. So this valve takes up much less space in piping than many other types of valves. The rate of fluid flow through a butterfly valve is adjusted by using the handle to change the angle of the disc. The handle is a lever that may include a spring-loaded locking device. To change the position of the valve's disc, compress the lever and turn the disc to the desired position. A lever with a locking device is frequently used as the handle on a butterfly valve because flow through the valve can sometimes cause the disc to flutter or change positions. Locking the lever in place helps the disc resist the force of the fluid flow and stay in the proper position. A diaphragm valve has a bell-shaped bonnet and a body that looks like two pipes that curve into the bonnet. As its name suggests, a distinguishing feature of a diaphragm valve is a flexible diaphragm that's used instead of a disc to seal against the valve's seating surface. A diaphragm valve also has no packing. Packing isn't necessary because the diaphragm forms a boundary that keeps fluid from leaking along the stem. A diaphragm valve has a part called a plunger that's connected to the valve stem. A diaphragm stud connects the diaphragm to the plunger. When the hand wheel of a diaphragm valve is turned in the closed direction, the stem and plunger are lowered. The plunger forces the flexible diaphragm down against the valve seating surface, which stops flow through the valve. When the hand wheel is turned in the open direction, the diaphragm moves upward, allowing fluid to flow through the valve. The diaphragm in a diaphragm valve isn't subject to uneven wear. So a diaphragm valve can be used both for throttling and for on-off service. The diaphragm also makes a tight seal that keeps fluid from contacting the operating parts of the valve. For that reason, diaphragm valves are commonly used in applications that involve corrosive materials and abrasive slurries. In addition, some diaphragm valves have protective liners made of plastic or a similar material. The liners protect the diaphragm and the valve body from damaging fluids. In short, diaphragm valves are widely used throughout industrial facilities for a variety of applications, but they're particularly useful in systems that carry chemicals or hazardous gases. A check valve is designed to allow flow in one direction only. It prevents backflow, which is the reversal of fluid flow in the piping to which the valve is connected. As long as it's in proper working order, a check valve operates automatically in response to system conditions. The valve remains open as long as fluid flows through it in the specified direction. But if fluid flow stops or reverses, the valve closes immediately. The body of a check valve is similar to the body of a globe valve, but most check valves don't have stems, handles, or hand wheels. Most check valves do have replaceable seats, discs, and caps. The cap is the top part of the valve body, which can be removed to provide access to the disc for maintenance. It's essentially the same as the bonnet on other types of valves. Several different types of check valves are available. We will look at three of the most common. The disc in a swing check valve is hinged at the top of the valve body by means of an arm and a pivot pin. When fluid enters, the disc pivots or swings away. This opens the valve and allows fluid to flow through. The flow through the valve is fairly straight, so there's minimal pressure drop across the valve. As long as flow is constant, the disc remains raised. If the flow stops, gravity and the change in fluid pressure pull the disc onto the seat, closing the valve. If flow reverses, the backflow pushes the disc against the seat to close the valve. If flow is intermittent, the resulting turbulence can cause the disc to alternately rise and fall or slam against the seat. The disc's repeated impact against the seat is called disc slam. Disc slam can damage the disc and the seat and result in leakage around the disc. For this reason, swing check valves are generally not used in applications where intermittent flow is common. A swing check valve, like other check valves, must be installed so that the direction of flow is under the disc. This disc position is necessary to allow fluid flow to raise the disc. It's also necessary because the disc depends, in part, on the force of gravity to pull it down onto the seat. The direction of flow for a check valve is often shown with an arrow cast into the outside of the valve body. As with any type of check valve, the disc in a horizontal lift check valve is positioned so that fluid will flow under the disc. When fluid enters the valve body and system pressure is greater than the weight of the disc is lifted off the seat. Fluid flows through the valve, then on through the outlet. When system pressure is reduced or flow is reversed, the disc moves down onto the seat.